Hey everybody, we are live and in stereo. Sulaiman Khan here, and it's about 1:30 a.m. in the morning, and I'm recording this video for you all because I was unable to conduct the live session today, and I had promised you that we were gonna go over the 2019 set of difficult MCQs as per the examiner report for IGCSE as well as O-level students, all variants. But unfortunately, because I was overwhelmed with a lot of work, because it's a busy season for us chartered accountants. June, July, August, it's a very busy season. So I do not have the time to conduct that live class. So I was in the office, just came back like an hour ago. But without further ado, I'll start solving these questions for you all and just upload this recording onto YouTube so that tomorrow, if we do a live session, we can go over the other years, right? Because I want to make sure that I do all the sets with you guys, which I have promised, right? So I'll try my level best. You guys just need to pray for me. Keep on sharing the videos, keep on spreading the word of knowledge, keep on helping each other out, and that's all I want. Yeah. So without further ado, let's just start off with the questions. Question number 1 says 4 fertilizers are each supplied in a 100 kg bag, right? Which fertilizer supplies the greatest mass of nitrogen per 100 kg bag? So we have to calculate the percentage by mass of nitrogen, right? So it's pretty easy. How do you calculate percentages? It's the mass of nitrogen, which is one nitrogen is here and the other nitrogen is here, and nitrogen you could check out in the periodic table is 14, times it by 2 because you have 2 nitrogens, divided by the entire mass, right? The entire compound's mass. So it's 14 because that's how you calculate percentages, right? It's part over whole into 100%. So divided by 14 plus hydrogen is 1 and you have 4 hydrogens, so times it by 4. 1 times 4 plus you have another 14, and then you have oxygen as 16, times it by 3 because obviously you have 3 O's right here, I'll show you, and then times it by 100% because I need to calculate the percentages out. So let's calculate the first percentage. So it's 28 divided by 28 plus 4 plus 16 times 3 multiplied by 100. That gives me 35%. So A has 35% by mass of nitrogen, right? Let's check out B. So B is 3 times N, because see, this NH4 whole thrice means you have 3 NH4s, which means you have 3 N's. 3 times 1, that's 3 N's. So I could say 3 times 14 divided by the mass of the entire compound, which is 3 times 14 plus 4 times 3, right? So 3 times 14 plus 4 times 3. Why am I multiplying 4 with 3? Because hydrogen is 1 and 1 times 4 gives me 4 right here, and then I times it by 3. So it's basically 1 times 4 and then multiplied by 3. Or what you could have done is you could have said, hey, this is 14, that's 1 times 4, which is 4, so 14 plus 4 is 18, and multiply 18 with 3, you would get the same answer as this. And then phosphorus is obviously 31 if I'm not wrong. You could check the periodic table out. Oxygen is 16, times it by 4 because obviously you have 4 O's, multiplied by 100%. What do I get, sir? That's 3 times 14, 42, divided by 3 times 14 plus 4 times 3 plus 31 plus 16 times 4. That multiplied by 100, that gives me 28.2%. So that's 28.2% by mass of nitrogen, right? What this actually means is that if I have 100 grams of ammonium phosphate, 28.2% or 28.2 grams would be of nitrogen. AKA if I have 100 kg of ammonium phosphate, 28.2 kgs would be of nitrogen, right? Then for C, you could say 2 times N. So 2 times 14 divided by the mass of the entire compound, which is 2 times 14 plus 4 times 2, because hydrogen is 1. So 1 times 4 is 4, 4 times 2, that's 8, plus sulfur is 32, oxygen is 16, times it by 4 because you 4 O's multiplied by 100%. What do we get, sir? 14 times 2, that's 28, divided by 2 times 14 plus 8 plus 32 plus 16 times 4 multiplied by 100%. That gives me 21.2. 21.2%. And then last but not least, let's calculate D, urea. So N times 2, which means 14 times 2 divided by the mass of the entire compound, which is carbon is 12, oxygen is 16, nitrogen is 14, but you times it by 2 because obviously you have two n's, and hydrogen is 1 multiplied by 2, that's 2, and then multiplied by 2, so that's 4, right? So 14 plus 4, that's 18. So I'll just write 18 here, and multiplied by 100%. What do I get? 14 times 2 divides, so 28 divided by 12 plus 16 plus 18, and then multiplied by 100%. So you get 60.87% of nitrogen by mass. And now it says which one has the greatest mass of nitrogen. Remember, the one which has the highest percentage by mass of nitrogen would obviously have the greatest mass, because the mass for all of the options is 100 kg. Let's suppose this was not 100 kg. This, in A part he gave you 180 kg, in B part he gave you 1000 kg, in C part he gave you 500 kg, in D part he gave you 200 kg. Then what you would have done is you would have taken these percentages and multiplied it with the relevant kilograms. So if you have 35%, you would multiply it with 180 kg to get the kilograms of nitrogen in 180 kilograms. If you have 28.2% of nitrogen biomass, you would multiply it with 1000 kilograms to get the kilograms of nitrogen, obviously. So if you had 500 kg of this entire thing, you would multiply it with the percentage biomass of nitrogen to get the kilograms of nitrogen. So in this case, the options may have differed and you would have multiplied it with their respective kilograms, but since all are 100 kg, I will ignore the 100 kg and be like, hey, if I multiply all of these with 100 kgs, obviously the one which has the highest percentage would have the highest would have the highest kilograms as well, right? So D is the correct option because it has the highest percentage. You could even multiply all of them with 100. This would give you 6087 kilograms compared to 2120 kilograms and whatnot, right? So this would be the highest kgs. Done. Now, moving on. Question number 2 says, calcium carbonate is heated, calcium oxide and carbon dioxide gas are formed. The equation is shown. 225 kilograms of calcium carbonate is heated until there is no further change in mass. The yield of calcium oxide is 85 kg. What is the percentage yield? Now, this is a very beautiful question and it's a very easy question. He's saying that percentage yield is the actual, when you want to calculate the percentage yield, you basically want to calculate the efficiency of your factory. Think of this entire question as your factory. In your factory, you're inputting 225 kgs of calcium carbonate and you're heating them, and this is what you're actually getting. The yield literally means output. So the output that you're getting from your factory is 85 kilograms of calcium oxide. But I want to find out, and obviously the output would obviously be lower than the theoretical mass that you're going to get, because obviously there are going to be losses, right? So I want to find out, the examiner wants you to find out that 85 kg, how much purity or how much yield is 85 kg, what is the percentage of calcium oxide that you're getting after you incur a lot of losses, right? So for that you need to also calculate the theoretical value. Theoretically speaking, 225 kgs, if I input 225 kgs in my factory, how much calcium oxide would I get if there were no losses? And that's simple stoichiometry. The first step for stoichiometry questions is to calculate the whatever is given into the moles, right? So convert the data into moles. So I'm going to say, hey, mass equal mole times molar mass. Mass is given, which is 225. Need to convert this into moles. Molar mass of calcium carbonate. Calcium is 40, if I'm not wrong. Carbon is 16 and oxygen is, carbon is 12 and oxygen is 16. Times it by 3 because you have 3 O's. What do you get? Moles. What are the moles of calcium carbonate that we're getting? Let's calculate that. So 40 plus 12 plus 16 times 3. That's 100. So 225 divided by 100. I get 2.25. So I get 2.25 moles of calcium carbonate. right? Now I don't need moles of calcium carbonate. What do I need? I need moles of calcium oxide. So I need to use the equation, right? So I know that 1 mole of calcium carbonate gives me 1 mole of calcium oxide. If 1 mole gives me 1 mole, 2.25 would obviously give me 2.25 moles of calcium oxide. Done. But now I don't need moles of calcium oxide. I need mass. So mass equal mole times molar mass. Mass I need to calculate. Moles is 2.25 and molar mass of calcium oxide. Calcium is 40 plus oxygen is 16. So you're going to get 56, right? So 2.25 multiplied by 56, I get 126 kgs. The reason why I'm writing kgs is because, and not grams, is because I took this in kgs. So the answer that I'm going to get is also going to be in kgs, right? So I'm going to get 126 kgs. Now, this is the mass that I would have gotten, theoretically speaking, if there were no losses. But in reality, in my factory, I'm only getting 85 kg. So what is the percentage purity? What is the efficiency of my factory? Should I close it or should I not close it? This is what the calculation that actually takes place in big factories when they want to figure out whether their factory is performing well or not. So X equals 85, you just cross multiply, X equals 85 times 100 divided by 126. What do we get? 85 times 100 divided by 126, we get 67.46%. So 67.46% is 67.5%, and the option is C, Reno. Yeah. Mind you, the reason why I'm taking a lot of time on these MCQs is because they are considered as the most difficult MCQs by the examiner as per the examiner report, which most of the students get wrong in this particular MCQ session, right? In this particular examination series. So I'm taking my sweet time in explaining every single concept in quite a lot of detail. Done. Moving on. Which gases are used to generate electricity in a fuel cell? So the hydrogen oxygen fuel cells that you've studied, you know that hydrogen and oxygen react to give you H2O, and that generates electricity as well, right, in a hydrogen oxygen fuel cell. So it's hydrogen and oxygen. It's not carbon dioxide and oxygen, not hydrogen and methane, not methane and carbon dioxide. It's basically hydrogen and oxygen. Done. Oxygen comes from air and hydrogen comes from either it can come from many sources. It can come from cracking of natural gas or cracking of methane, or it can come from not cracking of methane. It can come from cracking of hydrocarbons, cracking of alkanes, or it can come from natural gas. Not cracking of natural gas, what I was saying. It can come from natural gas, or it can come from cracking of hydrocarbons, and many other, or it can also come from the hydrolysis of the electrolysis of water. Please bear with me because it's like 2 a.m. in the morning, so just bear with me, and I've been tired. So it can come from many places, but remember, oxygen is obtained from air in a hydrogen oxygen fuel cell. Done. But that wasn't the question. I'm just giving you extra knowledge. Khair. Some properties of substance X are listed. It conducts electricity when molten, and we know what substance conducts electricity when molten. That's your ionic compound. They conduct electricity in molten state, and it says it has a high. But remember, if I talk about an ionic compound, that's true. It does conduct electricity in its molten state because it has mobile ions. But even if I talk about a metal will also conduct electricity in a molten state, in a solid state, in whatever state it is, because it has delocalized electrons. So it can be a metal, it can be an ionic compound. Let's see. Now it says it has a high melting point. Again, can be a metal, can be an ionic compound, because obviously they both have high melting point. Now it says it burns in oxygen, and the oxide dissolves in water to give a solution with a pH 11. Now that's a beautiful statement, because this is the statement which would segregate between it being a metal or an ionic compound. Now if it was an ionic compound, The problem is that, let's suppose I say it's NaCl. The problem is that NaCl does not react with oxygen to give you an oxide that dissolves in water. That's not what happens. No such thing has been studied by you guys, and that's not what happens. Otherwise, the salt, the edible salt, this is basically the edible salt. The edible salt at your homes would basically react with oxygen to give you an oxide or whatnot. But that's not what's happening. The salt in your kitchen remains the same as salt, right? So there's no such thing as this reaction taking place. But you'll realize that if you take a metal, for example sodium, and then you react it with oxygen, it'll give me an oxide. What oxide would it give me? Na2O. And I know that this oxide, if I add it to water, if I add a metal oxide to water, it's gonna give me a metal hydroxide, like sodium hydroxide, right? And that's gonna have an alkaline pH, because pH 11 means alkaline, right? It's an alkaline pH, because pH above 7 indicates that it's an alkali. And probably it's not sodium metal that he's using, because you'll realize that sodium does not have a high melting point. So it's and sodium's pH is around 13 or 14. So you could also segregate if it was, sodium or magnesium given, or maybe not magnesium, but if it was sodium and barium given, I'd probably select barium, because barium in fact has high melting. Group 1 metals are exceptions. They have relatively low melting points. So it has a low melting point, and the pH that it gives you, it's a more alkaline pH. This would probably not even be barium, it'll probably be magnesium. What is the element after magnesium? It's either gonna be probably it's magnesium, or an element lower than magnesium. So when that reacts with water, like calcium, yeah, it's probably calcium. But should you know which metal we are talking about? No. But you should also know that it's not sodium, because sodium has a high sodium does not have a high melting point, right? So it's probably calcium hydroxide, probably. It's sparingly soluble. That's why it's giving me a pH 11, not a higher pH than that. Because if it was sodium hydroxide, then it would be a pH of around 13 to 14. Yeah, makes sense. So it's not an ionic compound. It can't be a macromolecule, because a macromolecule, let's suppose you say it's graphite, right? Let's suppose you say it's graphite, because graphite also conducts electricity. Graphite also has a high melting point. But if you take graphite and you react it with water, it gives you carbon dioxide, which is an acidic oxide. So it'll have a pH lower than 11. It'll have a pH lower than even 7, right? So it can't be a macromolecule. A covalent compound, like, for example, I take SO2 as a covalent compound, and if I react it with first of all, covalent compounds, generically covalent compounds, if they are not macromolecules, they're not going to have high melting points. So you could eliminate A with that idea. And you'd also understand that covalent molecules or covalent compounds, they usually give you acidic oxide. Non-metal oxides gives me acidic oxides, right, which would not give me a pH of 11 when dissolved in water. Like if I take SO3 and dissolve it in water, it'll give me sulfuric acid, which does not have a pH of 11. It has a pH of around 1, 2, right? So you'll realize that the only option left is option C. Yeah. Again, I'm dissecting the most difficult MCQs by the examiner, so don't get panicked if you aren't able to wrap your head around these MCQs. I'm trying to break them down in quite a lot of detail, but if you still can't catch up, then you should probably revise your syllabus, right? This is why is cryolite used in the extraction of electrolysis. We know that cryolite is used for 2 reasons. Cryolite is an impurity, and what it does is that it lowers the melting point of aluminum oxide, because you'll realize that aluminum oxide, or you could say bauxite, the ore, because aluminum oxide is an ionic compound and it has a high melting point. So you want to make sure to use or to conserve as much energy as possible, and to use less energy. That's why you add an impurity, because you want to lower the melting point of aluminum oxide. Yeah. And the second reason is that you could also use it as a solvent. You could use it as a solvent. And the third reason is to dissolve the aluminum oxide. And then the third reason is, which is the more important reason, is that it also improves conductivity. It improves conductivity because it provides more ions to the solution. When you perform the electrolysis of aluminum oxide, you only have aluminum 3 plus and the O2 minus. But when you add cryolite, you also add sodium ions, and because you also add the aluminate ions, the sodium ions. So you add more ions, and the more ions there are, the more ions there are, you'll realize the more electrical conductivity would be improved, because more ions mean that more particles are there to carry the charge, right? So that's what it does. Now, it changes bauxite to aluminum oxide? No, it just reduces the melting point of aluminum oxide. It decreases the melting point of aluminum? No, it decreases the melting point of aluminum oxide, please. It dissolves the aluminum oxide. Yes, I told you, it is basically also acting as a solvent. So C is correct. Let's look at D. It says it protects the anodes from corrosion. No, the anode is still gonna corrode, because the anode is the positive electrode, and once oxygen forms at the positive electrode, because the temperature is too high, the carbon would react with oxygen to give you carbon dioxide, so it can't be protected. That's why extraction of aluminum results in global warming, because it forms a greenhouse gas called carbon dioxide. Yeah? The diagram shows the structure of a monomer and of the polymer made from it. Now, this is a monomer, and you also have polymer. What monomer is this? This is basically meth eth. This is ethene is the monomer, yeah? And this N just means the number of monomers that you're taking. N is just representing the number of ethene units that you're taking. And you've basically broken the double bond, you've shown the connectivity bonds and written N at the bottom, which means that this is now a polymer, right? And it has N number of repeat units, or N number of monomers. So this is ethene, and that's polyethene. Remember, it does become a single bond, but you still call it ethene. You don't call it ethane, right? Because it's made from ethene. So it's not A and it's not C. It can't be ethane, and the monomer is not ethane, that's ethene. So D is the correct option, ethene, and that's polyethene, done, which is plastic effectively. Now, which row describes the formation of single covalent bonds in methane? Now, how does a single covalent bond in methane form? If you look at methane, methane is a carbon bonded to 4 hydrogen, and there's a pair of electron being shared between the carbon atom and each of the hydrogen atoms, right? So it says atoms share a pair of electrons. Absolutely, that's correct. The carbon atom is sharing a pair of electrons. Are electrons transferred? No, C, D are wrong, because transfer of electron happens in ionic bonding. Yes, this is a covalent molecule, simple covalent molecule. Now it says both atoms gain noble gas electronic structure. Yes, that's the entire purpose of bonding, because you'll realize that hydrogen, it had one electron in its outermost shell, and it only has one shell. So once it shares an electron, now in the outermost shell of hydrogen there are 2 electrons, and the first shell can hold up to a maximum of only 2 electrons. So it does have the electronic configuration of a noble gas. For hydrogen, that noble gas is helium, and for carbon, you could check out the noble gas, the noble gas in front of carbon in the periodic table. So carbon gets that configuration. Let me also check which one does carbon get. I'm just gonna go over the periodic table because I'm not a machine, I don't remember. So if you look at carbon, if you take out your periodic tables, look at carbon goes to the electronic configuration of neon, right? Because carbon, it shares an electron with one hydrogen atom, the other hydrogen atom, the other hydrogen. So it shares electrons with 4 hydrogen atoms. Effectively, it has 4 more electrons. So if it was 6 on its own, now it'll be 10, and 10 is basically neon. So that's the entire idea behind bonding, to become a stable electronic configuration, that of noble gas. So A is the correct option. Both atoms have the same number of electrons in their outer shell. No, they don't. Carbon has 2, 4, 6, 8. Now carbon has 8 electrons in its outermost shell, whereas hydrogen only has 2 electrons. So B is wrong. Yeah. Okay. The positions of elements W, X, Y, and Z in the periodic table are shown. Which elements form basic oxides? Now, the ones that form basic oxides are obviously the ones that are metals, because you know that generally metals form metal oxides are basic oxides and non-metal oxides are acidic oxides. The Y that has been shown to you, Y is also metal. So W and X definitely will form basic oxides, right? Group 1 metal oxides, group 2 metal oxides, they are definitely basic oxides. But that's why C and D can automatically be eliminated, because it can't be Y only and it can't be Z only. It is either A or B, because Z is a non-metal, so this will probably form an acidic oxide, you know. And if I talk about Y is a transition element, right? Now you'll have to check out which transition element it is, because you also need to understand that metal oxides are basic oxides except for zinc oxide and your lead oxide. And lead oxide has now been removed from the code, so I'll remove that, and aluminum oxide. These are amphoteric oxides, not basic oxides, right? Because they act as bases as well as acids to give salt and water. Now Y, if you look at Y, let's check out Y. Y is right here in the periodic table. So let's check it out whether Y is zinc or not. If it's not zinc, then you're good to go. I'll add the periodic table here. Please pardon my low energy because obviously I'm tired. Now if you check this beauty out, this is basically copper that has been shown to you in the question. Zinc is the last element right here. Obviously I knew that from the get-go, but I wanted to show you how you would navigate your way in the paper. So the element shown to you is copper, not zinc. So copper oxide is in fact, see, if it was zinc, then he would have labeled this as Y, because that's the last element in the table. And then you move on to group 3, right? So Y is copper oxide, not zinc oxide. That's why Y is also a basic oxide. So W, X, Y all are correct. A is the correct option, right? Again, ethanoic acid is a weak acid. We all know, because it partially dissociates when, or partially ionizes when dissolved in water or in an aqueous solution. And this is a strong acid because this fully ionizes. Yes, sir. Now, one says ethanoic acid molecules are partially dissociated into ions. Absolutely, that's true. That's why it's a weak acid, you know. I can even show it to you. CH3 COOH, it partially dissociates. That's why we represent it with a reversible sign, CH3COO minus plus H plus ions, right? And that's aqueous. And we've studied this, that about only 1% of the ethanoic acid molecules of only 1% dissociates into the H plus ions. So the concentration of H plus ions is lower in ethanoic acid relative to HCl, because HCl it fully ionizes, so it has a higher concentration of hydrogen ions, right? And the higher the concentration of hydrogen ions, the lower the pH, right? Because the more acidic the solution is. So the pH for hydrochloric acid is lower. The pH of ethanoic acid compared to hydrochloric acid is higher. Obviously the pH of ethanoic acid would also be lower than 7 because it's an acid, but it'll have a higher pH compared to hydrochloric acid's pH, because hydrochloric acid gives you more H plus ions since it fully ionizes, right? So 1 mole of ethanoic acid has a higher pH than 1 mole per dm cube of hydrochloric acid. Yes, that's true. It does have a higher pH because it has lower H plus ion concentration. So the pH will be more towards 7. It'll be 5, 4, 5, but hydrochloric acid, because it's a strong acid, that's why it has a pH of 1 or 2, because it has more H plus ions. So 2 is absolutely correct. Then ethanoic acid is always more dilute than hydrochloric acid. Ethanoic acid is always more dilute than hydrochloric acid? No, dilution depends on the amount of water that you are putting, right? So if you add more water to ethanoic acid, it will be more dilute than hydrochloric acid. If you add more water to hydrochloric acid compared to ethanoic acid, hydrochloric acid would be more diluted. So dilution has nothing to do with weak or strong acid. Ethanoic acid is a proton acceptor? No, it's an acid. Acids are proton donors. So 1 and 2 is the correct option. The properties of an element are shown. Which element has these properties? Which properties are we now talking about? Let's see. It has high electrical conductivity, so it can definitely be metals. It has high electrical conductivity. Now it says that it has, so obviously B can be eliminated because B is, if you look at your group 3, let me show you. In group 3, that's your metal right here. Towards the left you have your metals, and towards the right you have your non-metals. So in group 3 the second element is aluminum. So yes, you can't eliminate it because B is basically aluminum. So all three could potentially be your answers. They all have high electrical conductivity because they're all metals. That's aluminum. B is aluminum. Yeah, always check out from the periodic table. Done. Now low density, it has low density. Automatically A is wrong, C is wrong, and D is wrong, because the only metals which have low density is what are your group 1 metals, right? That's why they float on water and they react violently with cold water. Down the group, for group 1s the reactivity increases, so they are gonna react violently with water. Even with this you could have circled D, because D has a low density, high electrical conductivity because of delocalized electrons, and this will react violently with water. You could eliminate B with this option right here, because aluminum does not react violently with water. In fact, it has an apparent unreactivity since it forms a layer of its oxide to protect it, right? So the correct option is D. 3 metal compounds PQR are heated using Bunsen burner. The results are shown. Colorless gas produced which relights a glowing splint. Now PQR are metal compounds. So metal, P can be a metallic compound. It's a compound, so probably a negative ion is also bonded to it, right? This is a colorless gas is produced. Okay, this MCQ has now been removed from your syllabus, but let's see whether we can solve it through the elimination method, because the strength of phosphates and carbonates and whatnot, they have been removed. But let's see if we can figure it out. But remember, this is no longer in our course. You could skip it if you want. Now in P it says a colorless gas is produced which relights a glowing splint, which means what gas relights a glowing splint? That's basically oxygen. Please, it's not hydrogen. Hydrogen gives a pop sound with a lighted splint. Oxygen helps in burning, that's why it basically relights a glowing splint. You should know this test, right? Then it says Q, so probably oxygen is being produced, and from this only you could eliminate A and B out if you've studied this, that magnesium carbonate, if you thermally decompose it, if you heat it, thermally decompose it, produces magnesium oxide and a colorless gas carbon dioxide. But carbon dioxide does not relight a glowing splint. It actually works opposite to this. So if there's a lot of carbon dioxide being produced, it would shut out the flame that you have, right? So it's between C and D, and in fact potassium nitrate is the one which produces oxygen. Yeah? Do you need to know this? No, you don't. Q, it says Q, a colorless gas is produced which turns lime water milky, and you know that colorless gas is carbon dioxide, and that should have been produced from a group 2 metal carbonate, which is magnesium carbonate. Therefore I would go with C, not D, because potassium carbonate does not produce carbon dioxide. Did you need to know this? No, you did not. Moving on to MCQ 12. Which row shows the conditions used for contact process? The temperature is 450 degrees Celsius. Now, examiner says a lot of MCQs couldn't distinguish between C and D's. Oh, you dumbo jumbo mumbos, you need to understand that the atmospheric pressure used in contact process is 2 atmosphere, not 200. 200 is used in Haber process. Please. And the catalyst obviously is vanadium pentoxide, it's not iron. Okay, the diagram represents a lime kiln used to heat limestone to a very high temperature. Probably limestone is heated to a high temperature to make cement, and that cement is later on used to make concrete, whatnot. Nobody cares about it. Now it says what leaves the kiln at X. This is no longer a part of your course. At X, this is not blast furnace, please realize it's something similar to that. But at X, what leaves is calcium oxide. That's the That's what happens when you take limestone and you thermally decompose it. It gives you calcium oxide, which is further used to make cement, and then that cement is used to make concrete, but nobody cares. This is no longer a part of your course. Not in course. Yeah. Okay. 25 cm cube of 1.1 mole per dm cube of sodium hydroxide is neutralized by 24.6 cm cube of dilute sulfuric acid. What is the concentration of sulfuric acid? Now again, this is a beautiful question. If it were to come in the theoretical paper, it would probably come for 4 marks or 3 or 4 marks, but in MCQ it has come for 1 mark. So you need to be smart about it. See, you're given the volume and you're given the concentration of sodium hydroxide. So you could calculate the moles of sodium hydroxide through N is equal to CV. N equals 0.1 multiplied by volume, which is 25 over 1000. Since you want to convert the cm cube into dm cube, what do we get? 0.1 multiplied by 25 over 1000. That's 2.5 into 10 raised to the power minus 3. These are the moles of sodium hydroxide. But I don't need the moles of sodium hydroxide. What do I need? I need the moles of sulfuric acid in order to calculate the concentration. Because you have the volume, you need the moles. Now, how do you jump from the moles of sodium hydroxide to the moles of sulfuric acid? You stitch it through an equation. And the equation is not given to you. And they expect you to write it because you know this reaction. Sodium hydroxide plus sulfuric acid gives me sodium sulfate plus H2O, and it gives me, you could balance it out, you have 2 NaOH, and here you have 2 times 1, that's 2 hydrogens here, and 2 hydrogens, that's 4, and here you only have 2 hydrogens. So I'll multiply this by 2, and I think that's a balanced equation for me. Yes, let's check this out. So you have, yes, that's a balanced equation. 1 sulfate on the right, 1 sulfate on the left, 4 hydrogens on the left, and 4 hydrogens on the right. 2 sodiums on the left, 2 on the right, and then obviously that's balanced, right? 2 O's on the left and 6 O's on the left. 4 plus 2, that's 6, and 4 plus 2, that's 6, right? Everything is balanced. Now you need to look at the equation and you'll see that 2 moles of sodium hydroxide reacted with 1 mole of sulfuric acid. So 2.5 into 10 raised to the power minus 3 moles would react with how many moles of sulfuric acid? Half, obviously. So 2.5 cross multiply 2.5 into 10 raised to the power minus 3 divided by 2. Sorry for my low energy again, I'm apologizing, but our main job is not to enjoy my energy rather, or focus on my energy, rather it is to try to solve all these difficult questions. So these are the moles of sulfuric acid, and then the last step is to convert the moles into concentration. So you have the moles, it's 1.25 into 10 raised to the power minus 3, and divided by the volume, because the volume is being multiplied here, divided, but make sure to convert it into decimeter cube. So 24.6 divided by 1000 is 0.0246, and what do we get? 1.25 into 10 raised to the power minus 3 divided by 0.0246. It gives me 0.0508 mole per dm cube, and you could check which of the options fit this. I believe it's A, and you're gonna go with A then. Make sense? Now, question 15. Hydrogen chloride has an MR of 36.5. It is released at P. The universal indicator turns red after 38 seconds. Okay, it takes 38 seconds. Now, since the experiment is repeated using sulfur dioxide. Sulfur dioxide is also an acidic oxide, so it'll also turn the universal indicator paper red. But how long will it take? You need to understand that if the MR is doubled, if you double the MR, the time it takes to diffuse is gonna increase because you have a fatter molecule. Remember, the higher the MR, the slower the particles are going to diffuse because they are fatter. Yeah, so I'm not body shaming, please, but if it took 38 seconds, it'll take more than 38 seconds. So this is 26, that's less, so I'm going to go with D. Make sense? Okay. RF values are used to identify unknown substances using paper chromatography. RF values, how do you calculate RF value? Distance traveled by the analyte or distance traveled by the substance divided by the distance traveled by the solvent front, right? Or the solvent. Which statement is correct? The RF values are always less than 1. That's true. RF values are always less than 1 because you need to understand that the distance traveled by the solvent front is always going to be greater than the distance traveled by the substance, right? So when you take the ratio, it's this, the smaller one, divided by the bigger one. So if the denominator is larger than the numerator, it'll always be less than 1. Yeah. RF value is equal to the distance traveled by the solvent. No, it's the distance traveled by the substance, not the solvent. The higher the RF value, the further the unknown substance travels. Yes, the higher the RF value, the closer it gets to 1. This divided by, if I say, hey, this, let's color it. This divided by the pink line is going to give you 0.8, 0.9. But if you take the smaller value and the denominator is again the same, the pink line, you're going to get a smaller reading from this. You're going to get 0.2, 0.4, something like that. So the higher the RF value, the further the unknown substance has traveled. Yes, the RF values are not affected by solubility of the unknown substance. The RF value is not affected by the solubility of the unknown substance. It is wrong. It is in fact affected by the solubility of unknown substance, because you need to understand, I've told you this in my live classes as well, that sometimes what happens is the RF value for a particular substance may even be 0. That means you would need to change the solvent, because that means that the substance is basically not soluble in that solvent. So the solubility of the substance in that particular solvent absolutely determines. If a substance is more soluble in a particular solvent, the RF value is going to be larger. But if a substance is less soluble in a particular solvent, the RF value is going to be slow. The RF value is going to be lower, right? So you need to understand that it is in fact affected by solubility. And you learn more about this in A2 chemistry when you talk about the mobile phase and the stationary phase, how the attraction between the solvent and the substance actually dictates how far it will travel, and the paper and the the substance. So you learn more about this in A2, but for now you just need to know this. Yeah, so it's 1 and 3. B is the correct option. What is the concentration of a solution that contains 25 grams of NaOH in 500 cm cube of water? Now 25 grams of NaOH, convert this into mass and convert this into dm cube. Yeah, how do you convert this into mass? Moles. Mass equal mole times molar mass, because he's given you the options in mole per dm cube. So convert this into moles and convert this into dm cube. So mass is 25, moles you have to calculate. Molar mass of NaOH, 23 plus 16 plus 1. N is equal to 25 divided by 40. So 25 divided by 40, what do I get? Divided by 40, sir, I get 0.625. These are the moles. And 500 into decimeter cube, 1 dm cube equals 8,000 cm cube. So 500 cm cube equals how many dm cube? X cross multiply, what do you get? 0.5 dm cube. So now what do you need to do? You need mole divided by volume, mole per dm cube. So 0.625 are the moles divided by the volume, which is 0.5. So what do you get? 0.625 divided by 0.5. Or you could use the formula N is equal to Cv and calculate concentration. That gives me 1.5 mole per dm cube. So 1.5 mole per dm cube. What is the correct option? C, Reno. Yeah. Which statement about the properties of elements of group 1 and group 7 is correct? Okay. Bromine displaces iodine from an aqueous solution of potassium iodide. That's absolutely correct, because bromine does in fact displace iodine from its salt solution, because bromine is more reactive than iodine. So it forms KBr, and a brown solution is also going to form a brown. You'll observe a brown the solution turning brown because of iodine aqueous. That's brown, yellowish brown. So B is the correct option. Chlorine, bromine, iodine are diatomic gases. They're not at room temperature. They're not diatomic gases. Chlorine is a gas. Bromine is a diatomic liquid. They are diatomic, but one is a gas, one is a liquid, one is a solid. Lithium, sodium, and potassium are soft non-metals. No, they're soft metals, not non-metals. So C is wrong. Lithium, sodium, and potassium has an increasing number of electrons in their outer shell. No, they have increasing number of electrons, but the outer shell electrons remain 1. Examiner said many students went for D. Outer shell electrons are all 1. That's why they are all in group 1. Yeah? So A is the correct option. Catalytic converters in cars, exhausts, change polluting gases into non-polluting gases, right? Which statement about oxides of nitrogen and car engines are correct? What happens in catalytic converter? You take unburnt hydrocarbons and it completely combusts it to carbon dioxide and water, and it takes nitrogen oxides, which I call NOx, and it is basically reacted with carbon monoxide, and you get nitrogen and carbon dioxide. Basically what happens is the carbon monoxide acts as a reducing agent, because it takes the oxygen from nitrogen, so from the nitrogen oxide it reduces it to nitrogen, and it itself becomes oxidized and forms carbon dioxide. So that's what happens, right? These are the products of a catalytic converter, and the products are H2O, carbon dioxide, and nitrogen. This is what statement is correct about oxides of nitrogen in car engines. The nitrogen in oxides of nitrogen comes from compounds in petrol? No, nitrogen in oxides from nitrogen comes from the high temperature of internal combustion engines. Because of the high temperature of the internal combustion engines, the nitrogen in the air is able to react with the oxygen and give you nitrogen oxides, which I call NOx, right? NO2 or NO. So it's not from compounds, nitrogen compounds in petrol. It's because of petrol is an alkene. Yeah. So it's not because of the nitrogen compounds that are present in petrol. It's because of the nitrogen in the air, which gets enough temperature, which is to achieve its activation energy and to react with oxygen to form nitrogen oxides. So 1 is absolutely wrong. The oxygen in oxides of nitrogen come from air in the car engine. Yes, it does come from air, and then it obviously reacts because of the high temperature, or it even reacts because when there's lightning it does react, because it provides it with the EA, the minimum energy that reacting particles must have in order to undergo successful collisions, aka react. Catalytic converters convert oxides of nitrogen into nitrogen and other gases. Yes, oxides of nitrogen are converted into nitrogen and other gases, as in you have like your beautiful carbon dioxide being produced as well. So 3 is correct. So 2 and 3, that's the correct option. B is the correct option, therefore. Yeah. Okay. Ammonia is manufactured in an exothermic. Wait, I'm getting a call. Hold up. It's too late. I'm sorry, but I'm just trying my level best to upload this as soon as possible. Okay, continuing from this question, ammonia is manufactured in an exothermic reaction. Forward, that means forward is exo and reverse is endo. Which effect of lowering the temperature on the rate of formation and equilibrium yield of what is the effect of lowering the temperature on rate? Remember, rate has nothing to do with reversible reaction. If you decrease the temperature, the rate of reaction would decrease, because it has to do with the collision frequency and the percentage of particles that possess the activation energy. If you lower the temperature, the frequency of collisions decreases, and the percentage of particles that possess the activation energy also decreases. So you need to understand that it has nothing to do with this reversible sign. So the rate of reaction would decrease. So C and D are therefore wrong. It would decrease, and the equilibrium yield, be it forward reaction, reverse reaction, rate would decrease, and equilibrium yield. So if you lower the temperature, lowering temperature favors exothermic, and therefore the equilibrium, which is the forward reaction, the equilibrium shift to the right, and therefore the yield of ammonia would increase. So B is the correct option. Yes. Which row shows the conditions used for Haber process? For contact process, it's repetition. We've already seen it. It's C. The diagram shows repetition. We've seen it. That's C. Okay. A section of polymer is shown. how many different types of monomer units formed this section of polymer. Remember, when it may seem very complicated, but if you know the simple rule that I've taught you, in order to find out the monomer, just put a cut at the linkage. You know that this is the ester linkage. Now you should be able to identify these linkages. COO is the ester linkage, and what you need to do is put a cut at the ester linkage, put a cut at the ester linkage, and you realize that between two cuts you're going to have your monomers. So that's monomer number uno, that's monomer number dos, and if you check this out, these are the connectivity bonds as well, right? And that's monomer number there's only two monomers, COO, COO, and then this is just being repeated, it's COO, COO, and there's CH2, CH2, that's COO, COO, CH2, CH2. It's basically this carbonyl carbon, this C double bonded to O will get back its OH, this will get back its OH, so it's a dicarboxylic acid, and this is a diol. So probably if it's a synthetic polymer, it's basically terylene, give it back, I'll show it to you even. This is basically the box that the examiner has shown to you, These are the boxes that he normally shades for you, remember? So basically what has formed is, if I draw the box here, the O and the O on the left hand side, they get their H's back. And if I draw the box here, the C double bonded to O, the C double bonded to O, they will get back their OHs. So it's a diol and a dicarboxylic acid, and this basically makes terylene. So if you check out how many different monomers, different types of monomers there are only two types, because this monomer is being repeated here and this monomer is being repeated here. So only two types of monomers. B is the correct option. An oxide of nitrogen has the following composition by mass. It has a relative molecular mass of 92. So that's the composition by mass. What is the molecular formula? So how do you calculate the empirical formula? First, see, from the percentages you calculate the empirical formula, and using the empirical formula and the molecular mass you calculate the molecular formula. So let's calculate the empirical formula. 30.4 is nitrogen and oxygen is 69.6, divided by 14 divided by 16. What do you get? By their ARs, right? So 30.4 divided by 14, I get 2.17. 69.6 divided by 16, I get 4.35, divided by the smallest ratio, which is 2.17. What do you get? I get 1:2. So for one nitrogen I have 2 oxygen. That's the empirical formula, remember. Now empirical formula, if I multiply it with the number n, I will get the molecular formula. So how do I calculate this n? Well, I know that the molecular formula has a particular molecular mass, that is 92. I need to calculate n, and I have the empirical mass. I can calculate it. 14 plus 16 times 2, 14 is nitrogen, 16 is oxygen, times it by 2 because you have 2 O's. So that gives me 46. So n is equal to 92 divided by 46, that is 2. So I will take the NO2 and multiply it with 2 to get the molecular formula. 2 times n, that's N2, and 2 times 2, that's 4. So that's O4. N2O4 is the molecular formula. I don't know why students have gotten this wrong, but hey, they have, so we will do it. I'm getting so tired, and you guys better be praying for me, for my health, for my longevity, and to God to continue to give me the strength to do this. It's, what time is it now? It's 2:30 a.m. Just pray for me, guys. I love you all. I'm doing this literally out of pure love for each and every one of you. I want every one of you to succeed and make me proud, inshallah. Okay. Calcium carbonate reacts with dilute hydrochloric acid according to the equation. 10 grams of calcium carbonate is reacted with 100 cm cube of 1 mole per dm cube of hydrochloric acid. The following statements are made. This much carbon dioxide is formed, this much calcium chloride is formed, this much carbon dioxide is formed, no calcium carbonate. Now, this is a pathetic MCQ because it will take a lot of time for us to calculate, because first of all what you need to do is, this is what he has done practically. He's reacted this practically. So you need to first of all figure out the limiting and excess rate. That's why I say do this MCQ at the end. If such MCQ comes, do it at the end. But between calcium carbonate and hydrochloric acid, you first of all need to calculate the limiting reactant. For that, you need to convert both into their moles, right? So convert both the data into moles. Let's convert calcium carbonate into moles. Mass equal mole times molar mass. I'm given the mass, which is 10 grams. Moles I need to calculate. Molar mass of calcium carbonate. Calcium is 40, carbon is 12, oxygen is 16. Times it by 3 because you have 3 O's. What do you get? 16 times 3 plus 40 plus 12. I get 100. So moles of 10 grams of calcium carbonate are 0.1. So I'm getting 0.1 moles of calcium carbonate, and then calculate the moles of hydrochloric acid. N is equal to Cv. You're given the concentration, which is 1, and volume is 100, but it's in cm cube converted in dm cube by dividing it with 1000. So 1 multiplied by 100 divided by 1000. What do I get? 0.1 moles. Now so you are basically reacting 0.1 mole of calcium carbonate with 0.1 mole of hydrochloric acid. But you need to figure out that between calcium carbonate and hydrochloric acid, which one is the limiting reactant. So you need to compare the two now. Calcium carbonate and hydrochloric acid. For 1 mole of calcium carbonate, you need 2 moles of hydrochloric acid, right? So if I have 0.1 mole of calcium carbonate, how many moles of hydrochloric acid would I actually require? 0.1 times 2. I would require 0.2 moles of hydrochloric acid. But how much is available? This working right here is done to figure out how much is actually practically being reacted together. This is what the student is doing in the laboratory, but what he needs to understand is that for every 1 mole of calcium carbonate, 2 moles of hydrochloric acid are required, right? So if you have 0.1 mole of calcium carbonate, how much hydrochloric acid would be needed? You would need 0.2 moles, but you're only reacting 0.1 moles, which means hydrochloric acid is the limiting reactant. That's the limiting reactant. And calcium carbonate, therefore, is excess. So no calcium carbonate is left. That's wrong. Calcium carbonate is indeed left over. Yeah. So 4 is wrong. Now, with the limiting reactant, we perform calculation. So with this limiting reactant, now I'll have to calculate the volume of carbon dioxide. So I know, okay, hey, I have 0.1 moles of hydrochloric acid. How much carbon dioxide, how many moles of carbon dioxide form? I don't know that, but I know that for 2 moles of hydrochloric acid, 1 mole of carbon dioxide forms. So for 2 mole, 1 mole forms, so 4.1, how many moles would form? N, cross multiply, what do you get? 0.1 divided by, 0.1 divided by 2, it's 0.05. So these are the moles of carbon dioxide. And now I need to convert this into volume. So 0.05 into 24. What do I get? I get 1.2 dm cube. So yes, indeed, I need to multiply this with 24 dm cube to find out the volume of carbon dioxide. So yes, in fact, 1.2 dm cube of carbon dioxide is being formed. So 1 is true. And if 4 is wrong, you could eliminate C and D. Now I just need to check out whether 2 is true or not. If 2 is true, or I could check out whether 3 is true. Because, you don't even have to check out whether 3 is true. Because see, now you have to use trick to solve this MCQ. I don't want to waste a lot of time. I will solve it for you, but if you realize that 2 and 3 can't be correct, because obviously, why am I saying 2? If you've realized that 2 and 3 can be correct, why can't C and D not be correct? Why can't C and D not be correct? Because D has 4, which is incorrect, and C does not have 1. 1 is correct, so C doesn't have. So the examiner required you to save time with this, right? And B is also incorrect because it has 4. So you could literally go with A option, right? You could literally go with A option. And yeah, I could prove this for you. I could calculate the mass of calcium chloride form as well, and I could calculate the mass of carbon dioxide form, but I'm too tired to do so, so you could do this. But in the exam, I'd request you to do it like this, because you now know that 4 can't be true, so you cancel out D, and you cancel out B because it has 4, and you cancel out C because you know 1 is true. So that's why I'm going for A. But you can calculate these two. It's the same thing. You use same hydrochloric acid to calculate calcium chloride mass, And how do you do that? Well, you calculate the mass by first finding the moles of calcium chloride and then converting into mass. Or if you want to find the mass of carbon dioxide, you find out the moles of carbon dioxide, which is 0.05 moles of carbon dioxide. Let's convert it into mass. Mass equal mole times molar mass. Mass of carbon dioxide equals mole is 0.05. Molar mass is 44 for carbon dioxide. So 0.05 times 44. See, it gives me 2.2 grams. And the question, it is said it's 4.8 grams. So C, 3 is wrong. So 1 and 2 is the correct option. Yeah. Okay, I'm so tired. Aqueous copper 2 sulfate is electrolyzed using copper electrodes. Okay, if you use copper electrodes, you realize that these electrodes, since they are not graphite, they are copper electrodes. The copper 2 plus ions are going to be deposited at the negative cathode. Panic, positive is anode, negative is cathode. So copper 2 plus ions are deposited at the negative cathode to give you copper, which is a pink solid. And because you're using copper electrodes, you'll realize that they're no longer inert. So they're going to dissolve in the solution to give you more copper 2 plus ions by losing 2 electrons. So at the cathode, this is what's going to happen. At the anode, this is what's going to happen, right? So at the cathode, copper 2 plus ions would gain 2 electrons to become copper. B is wrong and D is wrong. And between A and C, we know that this doesn't happen because this happens in graphite electrodes, not copper electrodes. In copper electrodes, because the copper is not inert, it will compensate, it will dissolve in the solution to compensate for the copper 2 plus ions being used up. That's why the blue solution, the blue color of the solution remains there, right? Is there, it's there, yeah. 10 grams of ammonium nitrate is added to water at 25 degrees Celsius and the mixture is stirred. The ammonium nitrate is dissolved and after 1 minute the temperature of the solution is 10 degrees. See, remember, if the temperature has decreased, it means cooling took place, and whenever cooling takes place, it's endothermic. In endothermic, everything cools down, even the reaction mixture, everything cools down in endothermic, and everything becomes hotter in exothermic. So is this endothermic reaction or exothermic reaction? It's obviously an endothermic reaction. Yeah. It's not it's not neutralization, because neutralization reactions are also exothermic reactions. It's just dissolving. He's just dissolving it. It's not reduction, because you could calculate there's no change in oxidation number. You know, ammonium nitrate, you add it to water, it's still ammonium nitrate. But in one case it was solid and now it's aqueous. Oxidation numbers stay the same. Okay. Now. Okay. Hydrogen reacts with chlorine according to the following equation. The reaction is exothermic. Okay. What statement is correct? The energy absorbed for bond breaking, if it's exothermic, that means the energy taken in during bond breaking is less than the energy given out during bond formation, which means bond formation mein energy given out is more than the energy taken in during bond breaking. Yeah. Energy absorbed for bond breaking is greater? No, it's less. Why? Because if it was greater, then it would be endothermic, not exo. Energy absorbed during bond breaking is less than the energy released in bond making. Yes, absorbed is less than released. That's what I've said. Bond formation may the energy released is more than absorbed. Energy released in bond formation is more than the energy taken in. That's why it's that's why it's exo. You know, I'll show it to you. Energy taken in is less and energy given out is more. So that makes it exo. Yeah, the enthalpy changes this. Energy released in bond breaking is greater. No, energy released is less. A and C are endo. Energy released in bond breaking is less than the energy absorbed in bond. See, energy is not released. First of all, energy is not released in bond breaking. Energy is absorbed. So C and D could be eliminated like this. Even by reading energy is released, you could say energy is not released in bond breaking. Energy is absorbed in bond breaking. So C and D are wrong. Okay. Okay. Some nitrogen dioxide gas was put into a gas syringe, blah, blah, blah. Its equilibrium, a react forward is exo, so forward is exo, backward would be endo. Which statement is correct? If the syringe is placed in a cold bath means you've decreased the temperature. Decrease in temperature favors exothermic, which is the forward reaction. And the forward reaction means it's going to become lighter brown or darker yellow. The dark brown would go into lighter brown or lighter or darker yellow type, you know. So this is the color becomes darker. No, it becomes lighter, you dumbo. It becomes lighter. This dark brown color becomes lighter, so it can't be A. If the if the gas syringe is placed in a hot water bath means what? Increase in temp favors endo, which is the reverse reaction or the backward reaction. So the color would get darker because you're gonna go towards darker brown. Here you're gonna go towards lighter. If you go forward, you'll become lighter. If you go backward, you'll become darker. So forward, you'll become lighter, not darker. Backward, you'll become darker, not lighter. So B is also wrong. So if the volume of the gas syringe is increased, now see, if you're increasing the volume, that means you're reducing the pressure, because pressure and volume, you've studied this even in your physics, that pressure and volume are inversely proportional. So increase in volume means you've reduced pressure, and decrease in pressure favors more gaseous moles. More gaseous moles are on the left hand side. So therefore the color should become darker, but here it's saying it becomes lighter, so C is wrong. Therefore D is the correct option. If the volume of the gas syringe is decreased, which means you're increasing the pressure, what decreasing volume means you're increasing pressure, and increase in pressure favors fewer gaseous moles. Fewer gaseous moles are on the right. You have 1 mole of gas on the right and 2 on the left, so fewer gaseous moles are on the right, therefore light, you're going to become lighter, and that's true, you are becoming lighter in D. Barium hydroxide is an alkali. It reacts with hydrochloric acid. Great, it does. Oh, what should I do about it? Kill yourself? Sorry guys for my tantrums. I'm just tired. How does the pH of hydrochloric acid change as excess barium hydroxide is added? So the hydrochloric acid pH would obviously there'll be an increase in pH, because hydrochloric acid would have a lower pH of 1. So if you start adding barium hydroxide, the pH is going to start to increase, and it's not going to just increase till pH 7. It's going to go above pH 7 because you're adding more alkali, and the more alkali you have, if you have excess alkali, the pH will become alkaline, which means the solution will become more alkaline, more basic. The pH is going to increase above 7. So the pH decreases from 14 to 1 and what? No, it goes from 1. It increases from 1 to about 14. Why? Because you're adding more alkali. So it increases from 1 and becomes constant at 7. It would have become constant at 7 in your case for O levels and IGCSE if you weren't using excess barium hydroxide and you just used the exact same amount or the mole. You used the exact proportion or the amount of barium hydroxide which was required to completely neutralize hydrochloric acid. But hey, you're using excess, which means you're going to become more alkaline. The pH is even going to go above 7 to about pH 14. So D is the correct option. Moving on to can I take a break of like a minute, because I'm just so tired, man. I just can't be bothered. Let's try to do it. How many structural isomers are there with the formula C4H10O? They are alcohols. कह रहे हैं कितने alcohols हैं? So if you make a 4 carbon alcohol, one is you could form meth eth pro bute, you could form butan 1-ol. You could also shift the position of the functional group to the second carbon, butan 2-ol. Some of you guys may say, sir, what if I put the OH here? What if I put the hydroxyl, or you would just say, what if I put this OH on the third carbon? Then it is not the third carbon, you dumbo. Then it becomes second carbon, because wherever the OH is closest, you start numbering from that side. So if the OH is here, you start numbering from the right to left. So then it becomes the second carbon. If you put it on the fourth carbon, it's not actually the fourth carbon, it will become the first carbon. So putting it here literally means the same thing. Putting it here literally means the same thing as this, right? So these are two ways, but some of you may now go for A, right? But you need to understand that it's not in fact A, because what you can do is you could also take this CH3 and place it on the middle carbon. Now if you place it on the middle carbon, what's going to happen is you're going to get something like this, and even if you want to name it, you could name it, you could select the longest carbon chain like so. This is 1, 2, 3. This is basically 2-methyl meth eth prop 2-methyl propan propan 2-ol, 2-methyl propan 2-ol, because on the second carbon you have the methyl and on the second carbon you have the functional group, so it's 2-methyl propan 2-ol, right? And some of you may even say, and these are CH3s obviously, some of you may say, sir, what if you take the OH and place it here? Yes, then the name will change. If you take the OH and place it on the first carbon in the same branched style, instead of having the OH on the second carbon, which was here, you now place it on the first carbon. Now the naming changes. Now it is 2-methyl. This was 2-methyl. See, the name, if the names are different, then obviously they are isomers. So this was 2-methyl propan 2-ol, and this is 2-methyl. On the second carbon you have methyl, and that's propan 1-ol, because it's on the first carbon, the OL, the OH, right? So they are both different. Now what if you say, sir, what if I put the OH here? What if I put the OH? See, this was a CH3. So, and these are, all three of these are CH3s. So if you put an OH here, 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 it's all the same thing. Because that's also a CH3, that's also CH3 bonded to the same carbon, that's also CH3 bonded. So try it. If you put the OH here, 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 they'll all end up being 2-methyl propan 1-ol. If you put the OH here, it will be 2-methyl propan 1-ol. If you, instead of here, you put it here, instead of here, you put it here, they'll all be propan 1-ol, right? Because wherever the OH is, you start numbering from that side. That's it. So it's actually, in fact, that's 1, that's 2, that's 3, that's 4. Done. So you have 4 structural isomers of butanol, right? This is butan 1-ol, that's butan 2-ol, that's 2-methyl propan 2-methyl propan 2-ol, that's 2-methyl propan 1-ol. Here, the concentration of aqueous sodium carbonate can be found by reacting hydrochloric acid of known concentration. The indicator used is methyl orange, which also, it's basically titration, right? Which, because sodium carbonate is saying it's aqueous, and that's also aqueous, so you're literally performing titration. For titration, we need a burette, we need a measuring cylinder, and you don't need a thermometer in this case. I'm not measuring temperature change, so B is wrong. Burette measuring, why do I need a gas syringe? I don't need gas syringe. I'm not measuring rate of reaction, I'm not measuring the temperature change, I'm just finding the neutralization reaction. I need a conical flask, yes, because I need to add from the burette to conical flask after I've poured in the volume of one of the solutions in the conical flask, right? So C is the correct option. Why do I need a stopper? C, B, A, D, there, all three of these are for calculating probably rate of reaction, and in particular B is for finding out temperature change as well. Okay. Which diagram best represents the structure of a solid metal? Please realize that it's B right off the bat, because it's a lattice of positive ions in a sea of delocalized electrons. See, he's given you the key here. It can't have a negative ion, so A is wrong. Now, if you check out C, some of you may go for C, but the problem with C is that the electrons are not delocalized. You know, he's shown it to you in a way. The electrons are moving throughout the structure. It's not like they're just present like this. You know, it's not like there are 4 electrons here, 4 here, 4 here. They're delocalized. They're moved all across. So C is wrong. And D, all the electrons are shown outside the structure, which is wrong. They're inside as well. They're everywhere, throughout the structure, in and out, everywhere, right? So D is also wrong. And if you check out B is, some of you say, sir, but it's not a lattice of positive ion. Use a pencil and you'd see that it's a lattice. The only cheeky thing that they've done is they've just increased the space between the positives. If you try to decrease the space in your mind and make them come closer together, literally it's a lattice, because it's a regular arrangement. You could literally see a pattern. Check this out. And many students got this wrong. And this is the sign of an electron. So yes, it is a lattice of positive ions in a sea of delocalized electrons. Helium and xenon are both noble gases. What is true about both? They are both chemically inert. Yes, noble gases, they don't react because they have a stable electronic configuration, and they both have 8 electrons in their outermost shell. No siree, because helium has 2 electrons in its outermost shell. It has a complete duplet, not a complete octet. So helium doesn't, therefore A is wrong. B is the correct option. Next, which substance is a metal? Metals have high melting points. It conducts electricity when Metals do have high melting points, and says it conducts electricity when solid. No, metals do conduct electricity when in solid state because it has delocalized electrons. So I'm going to cut off A, B, and I will also cut off C because metals, D, because metals do conduct electricity. That's why I said oh, because it was such a quick MCQ. I was happy. It has high melting point, it does conduct electricity in any state because it has delocalized electrons. Now, steel is produced by blowing oxygen into impure molten iron. A student suggests 2 reasons why this process is carried out. Which reasons are correct? Steel manufacturing is no longer a part of your course. But if you want to know, the oxygen removes carbon from the impure iron. The oxygen removes carbon from the impure iron. That's basically true because the impure iron contains carbon, the oxygen reacts with it to give you carbon dioxide. So that's true, but this is no longer a part of your course. The oxygen oxidizes iron to iron 3 plus ions. That's not what happens. Why doesn't that happen? Because it's already iron 3 plus ions, but who cares? Yeah, and fun fact, it's not even iron 3 plus ions. You have molten iron. It's iron, not iron 2 plus or 3 plus. It's just molten iron. So 2 is probably wrong. So the correct option is B, but this is not in course, so don't worry about it. Forget about it, and I can't be bothered to use my brain for this. The table shows the energy released by the complete combustion of some compounds. Which compounds releases the least energy when 1 gram is completely burned, right? So releases the least energy. Which of these would release the least energy? Now all of these are releasing energies. Which of these would release the least energy when 1 gram of it is burned? So what you need to do is you need to take 1 gram of all of these and figure out the moles, right? Because see, this is the energy change that's given to you for every 1 mole. So you need to convert all of these into moles and figure out, okay, hey, for every 1 mole, this much energy is being given out, 3270. So for the moles that I calculate, how much energy would be given out, so just convert it into moles. 1 gram divided by 78, 1 gram divided mass equal mole times molar mass, 1 divided by 78, 1 divided by 100, 1 divided by 114, and 1 divided by 44. What do you get? Calculate the moles. 1 divided by 78, I'm gonna get 0.0128. 1 divided by 100, I'm getting 0.01. 1 divided by 114, I'm getting 8.77 into 10 to the power minus 3. And then 1 divided by 44, I'm getting 0.0227. So these are the moles that I'm getting, and this for 1 mole, this much energy is released. So for 1 mole, this much is being released. So for 0.0128, how much would be released? So I'm just going to cross multiply. So basically what I'm doing is I'm going to take the moles and multiply it with the energy. So take the moles, multiply it with 3720, multiply this with 4800, multiply this with 5510, multiply this with 220. The only fact that you need to know that per mole, this is for every 1 mole, this much energy is given out. So for these many moles, because you're given only 1 gram, so for these many moles, how much energy will be given out? So you just cross multiply. So what do you get? 0.0128 multiply. I'm just rounding it off to quickly get this over with. So that's 41.9 kilojoules is given out. 0.01 multiplied by 4800, 48 kilojoules is given out. 8.77 into 10 to the power minus 3 multiplied by 5510, 48 kilojoules is given out. 0.0227 multiplied by 2200, that gives me 49.9 kilojoules. So the one that gave out the least amount of energy is in fact benzene. Yeah, who cares what benzene is? The least amount of energy that you are given out is 41.9 kilojoules. Yeah, that's 49.9. Makes sense? Done, dusted. Okay. which use of sulfuric acid are correct. The use of sulfuric acid is no longer a part of your course, but if you want to figure it out, it's pretty easy. It's just simple. As a bleach in the manufacture of wool pulp for paper, that's sulfur dioxide, not sulfuric acid. As a preservative in tin, again, that's not sulfuric acid. As a raw material in the manufacture of detergents, yes, sulfuric acid is in fact used in detergent. As a fertilizer, no, ammonium salts are used as fertilizers. So 3 is the only option that's correct. D, not in your course anymore. 9. Which organic compound requires the least mole of oxygen for the complete combustion of 1 mole of that compound? So you just need to balance the equations. This is your what's it called, carboxylic acid, so it doesn't even undergo combustion. So it's between alcohols and alkene and alkenes. This is my alkene. Okay, so let's say C4H8 plus O2, C3H8 plus O2, and then C3H7OH plus O2. Just need to balance out the oxygens, right? CO2 plus H2O, CO2 plus H2O, CO2 plus H2O. So the number of carbons that you have are the number of carbon dioxide that you are going to get, the moles, that's 3, and the number of hydrogens that you are going to have, half of those would form as water. So 8, so 4 would form, because 4 times 2 is 8, right? 4 times 2, that's 8, so half the number of hydrogens. So that's 4, that's 8, put a 4 here, that is 7 plus 1, that's 8, put a 4 here. Now balance the oxygens, right? So let's balance it. You have 4 times 2, that's 8, 8 plus 4, that's 12. So you have 12 O's on the right, and you only have 2 on the left. So what should I multiply 2 with to get 12? That's x is equal to 6. So I'm going to get 6 here. That's 3 times 3, that's 6. 6 plus 4, that's 10. So I have 10 O's on the right, and I only have 2 here. So what should I multiply 2 with to get 10? X is equal to 10 over 2, that's 5. So least number of moles. So automatically D is wrong. Now which is between C and A. Now you have 3 times 2, that's 6. 6 plus 4, that's 10. 10 O's on the right, and you already have 1 O here. So how many more do you need? I already have 1 oxygen. How many more do I need? I have 10 on the right, and I already have 1 here. So I need 9 more. So what should I multiply 2 with to get 9 more? X is equal to 9 over 2, which is 4.5, right? So you get 4.5, and therefore A is the least amount of moles. This is 5, this is 6, this is 4.5. 9 over 2 is 4.5. So I'll go with Reno. Yeah. Okay, moving on. This is what is the structure of propyl methanoate. Now again, propyl methanoate, you could draw it for yourself, and oh, thankfully 11 is just being repeated. 11 is A. Oh, thank the Lord. I was like, I'm just gonna quickly go over it, but now I'll explain it in a little detail. See, propyl methanoate, this means that it should have methanoic acid. It came from methanoic acid, and it came from propanol, right? Because the alcohol loses the H, and the carboxylic acid loses the OH. So you must have 3 H's bonded to the O, and then this O should be bonded to a C double bonded to. It can be like this, and it can also be like so. You could have C double bonded to O at the start, and then this is bonded to O. I'm just flipping it for you. So it's either CCC OCO and then H, and then it's COO CCC, right? So let's see. So this is CC. I'm just going to look at the C. So it's 2 C's, and then you have OO. That's absolutely wrong, because after 2 C's you can't get 2 O's, right? This is basically CH3, C bonded to the O, bonded to the O. So this is basically this is ethanoic acid. This came from ethanoic acid. This is ethanoate, not methanoate. So A is wrong. CH3, CO. Again, this is wrong, because CH3, C double bonded to O, single bonded. See, C bonded to O, bonded to another O. So that's also wrong. That's ethanoate, not methanoate. And then again, this is CH3. start from the, so okay, let's start from the left as well. So that's CH3 bonded to a CH2. Just open it up. Bonded to a C, which is bonded to an O, which is bonded to another O. So bonded to an O, bonded to another. So you see again, this is meth, eth, prop. This came from propanoic acid. This is not methanoic acid. This is propanoic acid, and therefore it's propanoate. This came from propanoic acid. You see, that's carbon double bonded to the oxygen and all the other carbons. That's what represents the acid bit, right? The alcohol bit is represented by the CO bond, not the C double bonded to O bond, right? Okay, so C is also wrong, and then D is the only option left, and that's even correct. You know, CH3 bonded to a C, bonded to two H's, bonded to another C, bonded to two H's, bonded to an O, bonded to a C, which is double bonded to an O, which is bonded to an H. So this makes sense. CH3, 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 CH2, CH2, bonded to O. So this is propyl, and this is meth. So propyl methanoate. Done. So D is the correct option. Pretty easy, man. Pretty easy. Just open the structure up for yourself, and that is it. Boom shakalaka. Thank me later. Pray for me, and I love you all. Just keep me in your prayers. I'm tired. I'm just gonna go and crash now. Bye. Ciao. Allah Hafiz.